topic which we are going to learn today is trigonometry. So let's start it. The first question arises is, what is trigonometry? So trigonometry is basically a combination of three Greek words, that is tri, gon and metry. The meaning of tri is three, gon is sides and metry is measure. So basically trigonometry is a branch of mathematics in which we learn the relationship of sides of a triangle. So now the question arises, why one should learn trigonometry? Where there is need to learn trigonometry, where it is being used in our day-to-day life. So suppose we come across a very tall building and we want to measure the height of that building. So actually using the concepts of trigonometry, we can find the height of that particular tall building without actually measuring it. Similarly, if there is a river and we want to measure the width of that river, then actually without using the concepts of trigonometry, we can find the width of that particular river without actually measuring it. So there are so many problems in our day-to-day life where we can use the concepts of trigonometry and we can solve our problems. So now, what's the side of a right angle triangle? As we know, a triangle which is having one of its angle as 90 degree is known as right angle triangle. As the sum of all the three angles of a triangle is 180 degree, so if one of the angle is 90 degree, it is obvious that rest two angles will be acute angle. Although trigonometry works for all type of triangles, but here in this chapter we will be learning the relationship of sides of a right angle triangle with respect to acute angles only. So here, if we are going to consider the angle C, suppose we are considering the angle C, then the side opposite to this angle C will be known as perpendicular. The side opposite to the angle C is known as perpendicular and which could be denoted as capital P. The side adjacent to this angle C is known as base and could be represented by capital B. As we know that the side which is opposite to the longest angle is longest. That's the reason in this triangle ABC, longest angle is your B. So the longest side will be your AC, that is known as hypotenuse, which could be denoted by capital H. So it must be clear that if we are going to consider angle C, in this case, AC, the side opposite to 90 degree, will be the hypotenuse. Side opposite to this angle which we are considering, that will be your perpendicular, and side adjacent to this angle will be your base. So for angle C, we can see that perpendicular will be side AB, base will be side BC, and hypotenuse will be side AC. Now instead of angle C, if we are going to consider angle A, in this case the side opposite to this angle A, that is your side BC, perpendicular will be side BC. Side adjacent to this angle A, that is side AB, will be the base, and hypotenuse obviously will remain same, that is your AC, because hypotenuse is always the side opposite to 90 degree only. So it must be clear to you that which side will be considered as perpendicular, which side will be considered as base, and which side will be your hypotenuse in a right angle triangle. Now let's see, we all know one of the most important theorem of a right angle triangle, that is your Pythagoras theorem. So as per your Pythagoras theorem, the square of hypotenuse is a square of perpendicular plus square of base. That means hypotenuse square is the sum of squares of perpendicular and base. It is a very important theorem of a right angle triangle, and using this Pythagoras theorem, if we are having any two sides of a right angle triangle, we can find the third side also. Now let's see what is trigonometric ratios. If we have taken a right angle triangle ABC in which angle B is 90 degree, and if we are going to consider this angle C, Suppose this angle C is your angle theta. In that case, as just now we have discussed, that the side opposite to this angle C, that is side AB, will be the perpendicular. Side adjacent to this angle C, that is BC, will be the base, and side opposite to this angle B, that is your AC, will be the hypotenuse. Now, using these three sides of a right angle triangle, we can find 6 ratios. These trigonometric ratios are sine, cosine, tangent, cotangent, secant and cosecant. The abbreviations of these angles are known as your sine theta, cos theta, tan theta, cot theta, sec theta and cosec theta. Theta we have considered as the angle C. We have assumed that this angle C is your theta. So these are the abbreviations which we generally use throughout the chapter. Now sine theta, that means sine of any angle, is your perpendicular over hypotenuse. That means ratio of perpendicular and hypotenuse is known as sine theta. Ratio of base and hypotenuse is known as cos theta. Ratio of perpendicular and base is known as tan theta. Ratio of base and perpendicular is known as cot theta. And the ratio of hypotenuse and base is known as sec theta. Similarly, ratio of hypotenuse and perpendicular is known as cosec theta. These are very important in this chapter. One has to learn all these ratios. It is very easy to learn all these ratios using this phrase, Pandit Badri Prasad Har Har Bol. From this Pandit we can take P, from here H, from here first letter of all these words we will be considering, and once we are considering P over H, that is your sine theta, sine of any angle. B over H is your cos theta. P over B, it is your tan theta. If we will go in the reverse direction, in the reciprocal of it, that is H over P, it is your cosec theta. H over B is sec theta and B over P is cot theta. So it is very easy to remember all these ratios using it. P over H sin theta, B over H cos theta, P over B tan theta, H over P cosec theta, H over B is sec theta, B over P is your cot theta. So from this we can even conclude that what is the relation between all these angles. From here we can say that cosec theta is reciprocal of sin theta. Sec theta is reciprocal of cos theta. Similarly, cot theta is reciprocal of tan theta. All these relations we can interpret using this relations only, this ratios only. Now suppose if we are considering, this angle C. So for sin C, that is your sin theta only we have considered. Perpendicular just now we have said it is your AB and hypotenuse is your AC and the base is your BC. So sin theta, or you can say sin C, will be perpendicular over hypotenuse, that is your ratio of AB over AC will be sin C. Similarly, cos C will be ratio of base and hypotenuse. Base over here is BC. BC over AC will be your cos C. Tan C will be perpendicular over base, that is AB over BC. Cot C will be reciprocal of tan C, that is BC over AB. Sec C will be reciprocal of cos C, that is AC over BC. Similarly, cosec C will be reciprocal of sin C, that is AC over AB. But instead of angle C, if we are going to consider angle A, in that case perpendicular will be your BC will be the perpendicular and AB will be the base. If we are going to consider angle A, in that case perpendicular will be side opposite to this angle A, that is BC. BC will be the perpendicular and base will be side adjacent to this angle A, that is AB. AB will be the base and hypotenuse will remain same, that is your AC. AC will be the hypotenuse. So if we are going to consider this angle A, then sine A, as we know that the sine of any angle is the ratio of perpendicular and hypotenuse. So sine of A will be perpendicular over here is BC and hypotenuse is AC. Similarly, cos of angle A will be base over hypotenuse. Tan of A will be perpendicular over base. Similarly, we can find all other trigonometric ratios for angle A also. We need to know that if we are going to consider this angle C, then AB will be perpendicular and BC will be the base. If we are going to consider this angle A, then BC will be perpendicular and AB will be the base. And ratio of sine of any angle is always the ratio of perpendicular to its hypotenuse. Similarly, cos of any angle is the ratio of base and hypotenuse. So it must be clear to you all that what trigonometric ratios are and how to find the values of these trigonometric ratios. Now let's see the relation between trigonometric ratios. As just now we have seen that cosec theta is the reciprocal of sin theta, sec theta is the reciprocal of cos theta, cot theta is the reciprocal of tan theta. So from these three relations, we can say that if we are going to multiply sin theta and cosec theta, the result will be 1. Similarly, cos theta and sec theta, multiplication of these two will give us 1, and tan theta multiplied by cot theta will be 1. Along with this, we can say that tan theta is the reciprocal of, is a ratio of sin theta and cos theta. As we know that sin theta could be written as perpendicular over hypotenuse and cos theta could be written as base upon hypotenuse. If we are going to divide these two, h is going to cancel and the result is p upon b, that is your tan theta. So tan theta could be written as ratio of sin theta and cos theta also. As we know that cot theta is the reciprocal of tan theta, so we can say that cot theta could be written as ratio of cos theta and sin theta, or we can say cos theta could be written as base upon hypotenuse, sin theta could be written as perpendicular over hypotenuse, that is your base upon perpendicular, that is your cot theta. So these are some simple relations which will be used in solving so many questions that we should know. So if we are going to repeat it again, so cosec theta is the reciprocal of sin theta, sec theta is the reciprocal of cos theta, cot theta is the reciprocal of tan theta. Along with that, tan theta could even be written as ratio of sin theta and cos theta. Similarly, cot theta could be written as ratio of cos theta and sin theta. Now, some important things to learn about is sin theta could not be written as sin multiplied by theta. As we do in algebra, like if it is written 2x, we can write it as 2 multiplied by x, but this does not work over here. Individually, sin, cos, tan does not have any value, so sin theta could not be written as sin multiplied by theta. When they are combined, when these trigonometric ratios are combined with any of the angle, then only they are having the values. Similarly, sin A plus B could not be written as sin A plus sin B, as it is a distributive property of multiplication over addition, as we say that A multiplied by B plus C could be written as A multiplied by B plus A multiplied by C, but this does not work over here. Over here, we cannot write sin A plus B is equivalent to sin A plus sin B, that we cannot write. Similarly, sin A over sin B could not be written as A upon B. We cannot cut sin and we cannot write it as A upon B. Sine theta raised to the power m, if it is like this, so we cannot write it as sine to the power m multiplied by theta raised to the power m. As we do in exponents, that it is ab raised to the power m could be written as a raised to the power m multiplied by b raised to the power m, but it does not work over here. We cannot write sine theta raised to the power m equivalent to sine raised to the power m multiplied by theta raised to the power m. But for our convenience, sine theta raised to the power m could be written as sine m theta. That means if it is like sine theta whole square, that simply means sine square theta. That means the meaning of sine theta whole square is equivalent to sine square theta. Both of them are same. We can write each of them, and the sine theta raised to the power 2 could be written as sine square theta. Now if sine A is equivalent to sine B, then we can say that A is equivalent to B. Here we have not cut these two signs, it's not like this, but still A could be written equivalent to B. How this is, we will be learning in this chapter only. Further we will be learning it. And it's not only for sine only, it is for all the trigonometric ratios. All these laws, all these works for all the trigonometric ratios. Now let's take an example. In a triangle ABC, angle B is 90 degree. If tan A is root 3, what will be the value of sin A? Here, it is given to us that value of tan A is root 3 and we have to find the value of sin A. So what we have done is we have taken a right angle triangle ABC in which angle B is 90 degree. Now we have to consider angle A. So if we are going to consider this angle A, so we know that the side opposite to this angle A, that is CB, will be the perpendicular, and side adjacent to it, that is BA, will be the base, and AC will be the hypotenuse. Now we have decided that which side is perpendicular, which is base, and which is hypotenuse. It is given to us as that tan A, it is equivalent to root 3. That could even be written as root 3 over 1. We know that tan of any angle is your ratio of perpendicular to its base. That does not mean that the value of perpendicular is root 3 and the value of base is 1. It simply means that the ratio of perpendicular and base is root 3 is to 1. So we can write perpendicular equivalent to root 3 times of any constant and base equivalent to k. 1 multiplied by k will be k. So we have taken out, we can see that the ratio of p and b is your root 3 over 1 only. So we can write p equivalent to root 3k and b equivalent to k. In a right angle triangle, by Pythagoras theorem, we can say that hypotenuse square is perpendicular square plus base square. So over here, hypotenuse is your AC. That simply means AC square is equivalent to perpendicular, that is your side BC is over here, it is root 3k, and base is your AB, it is equivalent to k. So AC square, hypotenuse square, is equivalent to perpendicular square, that is your BC square plus AB square. So value of AC square will be BC, we can write it as root 3 times of k square. Value of AB we can take it as k square. Now AC square could be written as square of root 3k will be 3k square, and this is your k square. So we can say that AC square is 4 times of k square, or AC will be root of 4k square, that is 2k. Here we will be considering only positive sign. We won't be considering the negative sign, as the side cannot be a negative. That's the reason we'll be considering AC equivalent to 2k. Now we know that sine of any angle is the ratio of perpendicular and hypotenuse. We know all the three sides of this right angle triangle. So the sine A could be written as ratio of perpendicular to its hypotenuse. Value of the perpendicular in this triangle is root 3k, and value of hypotenuse is 2k. So we can say, we can cut these two. So value of sin A will be root 3 by 2. So once we are knowing all the three sides of a right angle triangle, we can find all the trigonometric ratios. So now let's see the trigonometric table. So for some specific angles, we are having the values of the trigonometric ratios. That means for the angle 0 degree, 30 degree, 45 degree, 60 degree and 90 degree, we are having the values of all these trigonometric ratios. So what is the values of these trigonometric ratios and how to find it out? Let's see. See, the value of sine 0 degree is 0, sine 30 degree is 1 upon 2, sine 45 degree is 1 by root 2, sine 60 is root 3 by 2 and sine 90 is 1. How we can get it? If we are going to take over here in the numerator 0, 1, 2, 3, 4 and the square root of these numbers, that is square root of 0, square root of 1, square root of 2, 3 and 4, and then the denominator we will be taking 2, will be getting the values of all these sine thetas. That means root of 0 by 2, that will be your 0 only. So sine 0 degree will be 0. Similarly, root of 1 by 2, that is root of 1 will be 1 only. So sine 30 degree will be 1 by 2. Root 2 by 2 could even be written as 1 upon root 2. So sine of 45 degree will be 1 upon root 2. Sine of 60 degree will be root 3 by 2 and root of 4 is 2. That means sine of 90 could be written as 1. So it is very easy to find all the values of sine for the 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. Similarly, for finding the values of cos theta, that means cos 0, cos 30, cos of all these angles, what we need to do is from the sine theta table, from the line of this sine theta, will be coming from the right hand side to the left hand side. So if we will start moving from here, 1, that is sine 90 will be the value of cos 0. Then root 3 by 2, that is sine 60 will be equivalent to cos 30. Sine 45, cos 45. Sine 30 will be equivalent to your cos 60. Similarly, sine 0 will be equivalent to cos 90. So in this sine theta table, if we will move from here to here, we'll be getting the values of cos from left hand side to right hand side. Now for finding the values of tan theta, we know that tan theta could be written as the ratio of sine theta and cos theta. So if we will divide these two, values of sine theta and cos theta, will be getting the values of tan theta. So 0 divided by 1 will give you 0. 1 by 2 divided by root 3 by 2 will give you 1 upon root 3. 1 by root 2 divided by 1 by root 2, that is your 1. Sine 60, that is root 3 by 2 and cos 60, that is 1 by 2. If we will divide these two values, we will be getting root 3 and 1 divided by 0, that is infinite or not defined. So we will be getting the values of tan theta by just dividing the values of sine theta and cos theta. Now for finding the values of cot theta, again from right hand side to left hand side, we will start moving in the tail line of your tan theta. In the tan theta, if we will start moving from right hand side to left hand side, not defined will be the value of your cot 0 degree. Then root 3 will be the value of cot 30 degree. Similarly, will be 1. It is here 1 by root 3 and over here it will be 0. Now for sec theta, we know that sec theta is the reciprocal of cos theta. So if we will reciprocate the values of cos theta, we will be getting the values of sec theta. See over here, if we will reciprocate 1, it will be 1 only. Root 3 by 2, if we will reciprocate it, numerator to denominator and denominator to numerator, it will become 2 by root 3. Over here, it will be root 2. 1 by 2 reciprocal will be 2 and reciprocal of 0 will be not defined. Similarly, cosec theta could be written as reciprocal of the sine theta, or in the sec theta table, if we will go from right hand side to left hand side, we will be getting the values of cosec theta. And if we will take the reciprocal of sine theta, so it will be reciprocal of 0 will be not defined, reciprocal of 1 by 2 will be 2, reciprocal of 1 by root 2 will be root 2, reciprocal of root 3 by 2 will be 2 by root 3 and reciprocal of 1 will be 1. This is how easily we can learn the table of your all these values, all these your trigonometric ratios for these particular specific angles. It is very important to learn this table, to remember how to make this table, how we can make this table. Now if we are going to see this table carefully, we can see that the values of sine theta and cos theta the maximum value of sine theta and cos theta is 1. Can you guess why? See, the value of sine theta, as we know that the sine theta could be written as ratio of perpendicular and hypotenuse. Similarly, cos theta could be written as base upon hypotenuse. And in a right angle triangle, the longest side is always the hypotenuse. So if we are going to take the ratio of perpendicular to hypotenuse or base upon hypotenuse, always denominator will be bigger than the numerator, and that's the reason value will always be less than 1 or equivalent to 1. So maximum value for sine theta and cos theta could not exceed 1. Now let's see an example related to this concept only. If in a triangle ABC, angle B is 90 degree, that means a right angle triangle is given to us. This is a right angle triangle. Suppose this is your triangle ABC in which angle B is 90 degree. If the angle theta is your 30 degree, suppose we are assuming that this angle C is your theta and this theta is given to you as 30 degree, what will be the value of sine square theta plus cosec square theta plus cos square theta minus cot square theta? So from the table we can easily see that sine 30 degree, sine 30 is 1 upon root 2. So sine 30 degree is 1 upon root 2. Similarly, cosec 30 is 2. Value of cosec 30 is 2. Sine 30 is your 1 upon 2. Not 1 upon root 2. Value of sine 30 is 1 upon 2. Cosec 30 is 2. Cos 30 is root 3 by 2. And value of cot 30 is root 3. So these are the values we have taken directly from your table. Now keep these values in this expression. So sine square 30, as we discussed, that sine square 30 could be written as sine 30 whole square. So sine square 30 could be written as sine 30, value of sine 30 is 1 upon 2 whole square plus cosec 30 is 2. So it could be written as 2 square plus cos 30 is root 3 by 2. So square of root 3 by 2 plus cot 30. Over here it is minus sign, so we will be taking minus sign here. Root 3, value of cot 30 is root 3, so root 3 square. So we have kept all the values in this expression. Now we will be solving it. The square of 1 upon 2 will be 1 upon 4. Square of this 2 will be 4. Square of root 3 by 2 will be 3 by 4, and square of root 3 will be 3. We can take these two. Over here 1 by 4 and 3 by 4, both are having denominator 4. So we will take both of them aside. We will be making pair of this. 1 upon 4 plus 3 upon 4 plus 4 minus 3. We have taken both of them together. So over here if we will be taking LCM, it will be 4 only, and the numerator will be 1 plus 3. And 4 minus 3 is 1. 1 plus 3 will become 4, and 4 upon 4 will be 1, and 1 plus 1, it will be 2. So if questions are like this, so directly from the table we can find the values, and if we will be keeping in the expression, we will be getting the value of the expression. Now let's see how to find the values of the trigonometric ratios for some specific angles. Suppose the angle which we are taking is your 45 degree. So what we have to do is we have to find all the values of trigonometric ratios for angle 45 degree. Now we have taken a triangle PQR which is right angled at Q, that is angle Q is 90 degree, and we have taken angle R as 45 degree. As we know that sum of all the angles of a triangle is 180 degree. So if one of the angle is 90 degree, another is 45 degree, so it is obvious that the third angle will even be of 45 degree. So here we can see that angle P and angle R both are your 45 degree. That means triangle PQR is an isosceles triangle. And in the isosceles triangle, by the converse of isosceles triangle property, the sides opposite to the equal angles are even equal. That means side opposite to this angle R, that is PQ, will be equal to the side opposite to this angle P, that is QR. Suppose we are assuming that these two sides are x. The measure of these two sides is x. So, in a right angle triangle, by Pythagoras theorem, we can say that the square of the hypotenuse is equivalent to square of base plus square of perpendicular. That means over here, this, if we are going to consider this angle R, then side opposite to this, that is PQ, will be the perpendicular, and QR, that is adjacent to it, will be the base, and PR will be the hypotenuse. That means PR square will be equivalent to QR square plus PQ square. So we can say we have to find the value of the PR. So PR square is equivalent to QR, we have assumed to be x square plus PQ is even x, so it will even be x square. So PR square will be equivalent to 2 times of x square, or we can say that PR will be root of 2x square or root of 2x. So this is how we can find the third side of a right angle triangle. So here we can say that for angle R, for this angle R, perpendicular is your PQ, that is x, base is QR, that is x, and hypotenuse is PR, that is 2 times of x. And once we are having all the three sides of a right angle triangle, we can find all the trigonometric ratios. So let's find it out. So angle R is 45 degree. So sine 45 is the ratio of perpendicular and hypotenuse. So perpendicular is x, hypotenuse is root 2 times of x. X and x both are going to cancel. So value of sine of 45 degree will be 1 over root 2. Similarly, cos 45 will be base upon hypotenuse. Base is x, hypotenuse is root 2 times of x, that is equivalent to 1 upon root 2. Similarly, we can find all other trigonometric ratios also for the angle 45 degree. Now let's see how to find trigonometric ratios for 30 degree and 60 degree. For this, we have taken an equilateral triangle PQR. We know that in equilateral triangle, all the three sides are of equal measure and all the angles are 60 degree. So angle P, angle Q, angle R, all are 60 degree, and we are assuming that all the three sides are of x. The measure of all the three sides is x. So in this triangle, from the vertex P, we are going to draw a median which is intersecting the side QR into two equal halves. So from here, we have drawn a median, suppose, which is intersecting the side QR at the point T. This is the point T which is dividing QR into two equal halves. The median of an equilateral triangle is the perpendicular bisector, as we know that, and it is the angle bisector even. That's the reason this angle will be your 30 degree. Half of 60 degree, that is 30 degree. Now we are considering the triangle PQT. So we are taking a triangle, here it is PQT. This angle is 30 degree, this is 90 degree, and this is 60 degree. So in this right angle triangle, we know that side PQ, it is x, we had assumed it, and QT is the half of x, that is x by 2, because T is the midpoint of QR. Now in this right angle triangle, by Pythagoras theorem, we can say that PQ square, that is your hypotenuse, PQ square will be equivalent to PT square plus QT square. Value of PQ is x, so we can write it as x square. We need to find the value of PT, so we will keep it as it is. PT square, QT is x by 2, so x by 2 square. So we can solve it further. X square is equivalent to PT square plus x square by 4. So PT square will be x square minus x square by 4 if we will be solving it further, we'll be taking LCM, that will be 4, and it could be written as 4x square minus x square, that is 3x square by 4. Or we can say that PT is root of 3x square by 4, that is root 3x by 2. So now we are going to consider this angle Q, that is 60 degree. So if angle Q we are considering, which is 60 degree, for this side opposite to this angle, that is PT, will be the perpendicular. Perpendicular will be PT, that is root 3x by 2. Base will be side adjacent to it, that is QT, and it is equivalent to x by 2. And hypotenuse is PQ, that is x. From here, because we are having all the three sides of a triangle or right angle triangle, so we can find all the trigonometric ratios. So sine 60, that is ratio of perpendicular to hypotenuse, will be root 3x by 2 divided by x, that is value of the hypotenuse, that will give you root 3 by 2. Both x are going to cancel and the value of sine 60 will be root 3 by 2. Similarly, cos 60 will be the ratio of base and hypotenuse. Base is x by 2, hypotenuse is x, so it will be 1 by 2. Similarly, we can find all other trigonometric ratios for sine 60 degree, as we have find it of sine 60 degree, cos 60 degree. Similarly, for the theta 60 degree, we can find all other trigonometric ratios. Now, if we are going to consider angle P, that is your 30 degree, if we will consider angle P, which is 30 degree, for this perpendicular will be side opposite to it, that is QT will be the perpendicular. So perpendicular will be QT and its value is x by 2. Base will be PT, that is root 3x by 2, and hypotenuse is PQ, that is x. So sine 30 degree will be perpendicular over hypotenuse, that is x by 2 over x, that is 1 by 2. Similarly, we can find cos 30, that is base upon hypotenuse, and it will be root 3x by 2 divided by x, that is root 3 by 2. Similarly, for 30 degrees, we can find all other trigonometric ratios. In the same way, we can find for 0 degree also, 90 degree also, and this is how our table is formed, which we discussed just now. Now let's see the trigonometric identities. Identities are the ones which is true for all the values of the variables. So for trigonometry, we are having three main identities, that is sin square theta plus cos square theta is equivalent to 1. It is true for all the values of theta, all the three identities. 1 plus tan square theta is equivalent to sec square theta, and 1 plus cot square theta is equivalent to cosec square theta. So from these three identities, we can interpret from this first one, we can say that the value of sin square theta is 1 minus cos square theta. That means sin square theta could even be written as 1 minus cos square theta. Similarly, cos square theta could be written as 1 minus sin square theta. From the second identity, that is 1 plus tan square theta is equivalent to sec square theta, we can say that sec square theta minus tan square theta could be written as 1, and tan square theta could be written as sec square theta minus 1. Similarly, from the third identity, that is 1 plus cot square theta is equivalent to cosec square theta, we can say that cosec square theta minus cot square theta is 1, or cot square theta is equivalent to cosec square theta minus 1. These three are very important and are used to solve many problems related to trigonometry. Now, how to derive all these three identities? Let's see. Suppose we have taken a right angle triangle, that is triangle ABC, which is right angled at angle B. In this case, suppose we are considering this angle C, that is your angle theta. So in a right angle triangle, we know that by Pythagoras theorem, hypotenuse square, that is square of AC, is equivalent to base square plus perpendicular square. So we can write AC square is equivalent to AB square plus BC square. That is in triangle ABC. We have written this by Pythagoras theorem. Now see, if there are three terms are there, that is AC square, AB square and BC square. If we are going to divide this whole expression, this whole equation by AC square, then what we will be getting? AC square over AC square, it is equivalent to AB square over AC square plus BC square over AC square. AC square and AC square both are going to cancel. So it will be 1 equivalent to AB over AC whole square plus BC over AC whole square. So now if we are going to consider this angle C, that is your angle theta, then side opposite to this angle C, that is AB will be the perpendicular and BC will be the base. So AB over AC, that means perpendicular over hypotenuse. AC is your hypotenuse. So perpendicular or hypotenuse is your sine theta. So we can say that 1 is equivalent to sine square theta plus BC over here is your base and AC is the hypotenuse. So base upon hypotenuse is your cos theta. So it is your cos square theta. So we have proved the first identity, that is 1 equivalent to sine square theta plus cos square theta. Now similarly, if instead of dividing it by AC square, if we are going to divide this whole equation by AB square, so we will be getting AC square upon AB square is equivalent to AB square upon AD square plus BC square upon AD square. AC upon AB. AC over here is your hypotenuse. So it is hypotenuse. AB is perpendicular upon perpendicular square. AB square both are going to cancel. It will become 1. BC is base. Base upon AB is perpendicular square. So we know that the hypotenuse upon perpendicular is your cosec theta. So cosec square theta is equivalent to 1 plus base upon perpendicular is cot theta. So cot square theta. So from here we have proved the second identity. Similarly, if we are going to divide this whole equation by BC square, we will be getting the third identity. So if we are going to divide it, we will be getting AC square upon BC square is equivalent to AB square upon BC square plus BC square upon BC square. AC over here is your hypotenuse. So it is hypotenuse. BC is base. Hypotenuse over base square is AB is perpendicular and BC is base. Perpendicular over base square plus BC square and BC square both are going to cancel and we will be getting it 1 over here. So hypotenuse over base is your sec theta. So it will become your sec square theta is equivalent to perpendicular over base is tan theta. So tan square theta plus 1. From here we can prove the third identity also, that is sec square theta is equivalent to tan square theta plus 1. So it's very easy to prove all these three identities. We need to learn all these three identities because directly or indirectly it will be used in solving so many problems. Now let's solve some problem based on whatsoever we had learned till now. The first question is sec A multiplied by 1 minus sin A multiplied by sec A plus tan A equivalent to 1. We need to prove LHS equivalent to RHS. So we'll be taking LHS first. In these type of questions, we just try to convert everything in terms of sine and cos. So over here sec theta is there, tan theta is there, and we can convert these in terms of sine theta and cos theta. So what we'll be doing is, we'll be taking sec A, and sec A could be written as 1 upon cos A. So we are taking directly your LHS part. Sec A we have written as 1 upon cos A. We'll be taking this as it is 1 minus sin A. Multiplied by again sec A could be written as 1 upon cos A plus tan A could be written as sin A upon cos A. So it will become 1 minus sin A upon cos A. Here both the denominators are cos A, so it will be cos A only multiplied by numerator will become 1 plus sin A over cos A. In the numerator we will see it is A minus B, A plus B. So for the identity it is A plus B. A minus B could be written as A square minus B square. So we will be writing it as A square, that is 1 square will be 1 minus sin square A over cos A multiplied by cos A will be cos square A. This could be written as cos square A. Now we have seen the identity that sin square A plus cos square A is 1. From here we can say that 1 minus sin square A could be written as cos square A. So we will be writing the numerator cos square A upon cos square A, that is equivalent to 1, and it is your RHS. So hence proved. Now take the another example, that is root of 1 plus sin A over 1 minus sin A, it is equivalent to sec A plus tan A. Again we will be taking the LHS part. In these type of questions we rationalize the denominator. So what we will be doing in the denominator, it is negative sign, that is 1 minus sin A. So we will be multiplying and dividing it by 1 plus sin A. We have taken this 1 plus sin A over 1 minus sin A as it is, and for rationalizing we have multiplied it by 1 plus sin A over 1 plus sin A. In the numerator and denominator we have multiplied it by 1 plus sin A. So in the numerator it is 1 plus sin A multiplied by 1 plus sin A, that will become 1 plus sin A whole square, and in the denominator it is 1 minus sin A into 1 plus sin A, that could be written as A square minus B square. A plus B, A minus B could be written as A square minus B square. So over here in the numerator it is square of 1 plus sin A, and it is in the square root sign. So it will come out of the square root sign and it will become 1 plus sin A. And in the denominator it is 1 minus sin square A, that we have just now seen that it could be written as cos square A. So we will write in the denominator cos square A, and square root of cos square A will be cos A. So we can write it as 1 plus sin A over cos A. Now we can write it separately even. So it will become 1 upon cos A plus sin A over cos A. As we know, 1 upon cos A, that is reciprocal of cos A, could be written as sec A, and sin A over cos A could be written as tan A. And this is your RHS. So hence proved. So using all the formulas whichsoever we have studied, we can solve all these type of problems. Now it's time to check that how much the topic is clear to you. So there are 3 questions for you. You need to solve these questions. The first question is that if there is a triangle ABPQR in which angle Q is 90 degree and sec theta is 2, what will be the value of sin P multiplied by cos R? The second question is find the value of 2 tan square 45 degree plus cos square 30 degree minus sin square 60 degree. In the third question, you need to prove that cos A over 1 plus sin A plus 1 plus sin A over cos A is equivalent to 2 times of sec A. So 3 questions are here. Please do solve these questions and comment your answers so that I'll check it out how much it is clear to you, how much the topic is clear to you. Hope you must have enjoyed the video and you must have liked it. Your concepts of the trigonometry is clear. Soon we'll be coming with more videos on trigonometry, few questions related to that which are generally asked in the board exams, and more topics on 10th based on 10th standard. Thank you.